Class, our next lab will be on a Wheatstone Bridge. I'm going to briefly explain what a Wheatstone Bridge is, and after I do this explanation, we'll start our lab. A Wheatstone Bridge is a equipment that will measure unknown resistance. And so we'll say that this is an unknown resistance, and we have this bridge set up. We have our battery hooked to the bridge, and what happens, we'll have current flowing through these two resistors, and also we'll have current flowing through these two resistors. And this resistor here, which we'll be using a resistance box, will be a variable resistor, sometimes called a potentiometer. And we can vary this resistor until no voltage flow through this circuit. And so at the time we have no voltage flowing through the circuit, we can compute this unknown resistance, and I'll show you how that's done in a minute. But our setup, our Wheatstone Bridge looks a little different. What we have is a long wire hooked to a board which will represent resistor A and resistor B. So we have half of this wire we'll call RA, the other half we'll call RB. Now we'll put our unknown resistor in, which in our case, we will measure the resistor to make sure that our readings is accurate. So we have our unknown resistor hooked to ground, hooked to the voltmeter, and we'll jockey along the A and B resistor till we find a position that we have 0 volts, just as we did with this Wheatstone bridge. And our resistance box, which is representing this, our variable resistor is hooked to the positive end of the battery and the ground, just like RX is hooked to the ground. And so when we jockey along here, we'll jockey along here until we get 0. Then we'll measure these two lengths, LA and LB, and we'll relate these lengths to the resistors. So here we have RA is to RB. Here, RA is to RB, as RX is to R box, as RX is to R box. So when we solve for Rx, we'll have R box times RA over RB. And of course, RB is just 100 centimeters, the length of our wire that we're jockeying along, minus RA, the position where we get the voltage at 0. To come look at our setup, we have the negative end of this battery connected to the far end of our Wheatstone Bridge. And then we have this, what we call a resistance box, which we have set on 30 ohms, connected to ground, and the other end hooked to the hot end, the negative end, where we have our battery hooked. Then we come to, from the positive end of our battery to Rx, the resistor which we are looking, the resistance which we are looking for. And here, we have our voltmeter. Our voltmeter is hooked one end to the jockey and the other end hooked to common. Now, you will notice when we push down here, we have a negative reading. We slide it all the way to the right. We have a positive reading. So in between this negative and positive reading, we should get a 0. Half of this wire, that's RA, and then another portion of it is equal to RB. So the wires are the two resistors that we're using, like in our Bridgestone bridge. So we'll jockey. Now watch what happens. We're looking for a point. Where we get 0.
So once you start, you can do a couple things. Assembly, for us, outside is 3 assembly is going to have market parts. And do the same.
We're getting close. So this point is at 0 is at 56, and I'm going to say 0.5 centimeters. So now we'll do our math. We'll take 100 minus 56.5 centimeters, and that should equal 0.5 centimeters. Okay, I went on and did some of the math. We take 100 centimeters from 43.5 centimeters, and we get 56.5 centimeters, which is 0.76. When you divide 43.5 by 56.5, you get 0.76. And Rx is going to equal 0.76 times 30, which is the box, which comes out to be 23 ohms.